Okay, back to where we left off. Okay, so we were plugging in -1. Now if we plug in 0, I change colors because I'm gonna, I don't want the red graph. I want the red graph to be different than the blue graph. So I change colors because I'm graphing. By the way, this 1 right here, it's a change to the equation. It's a change to the function. It's called a parameter change. P-A-R-A. And no, I may not be spelling this right. It's a parameter change. A change to the equation is called a parameter change. And what it causes, parameter changes cause changes to the graph. And the change to the graph is called a transformation. Changes to the graph are called transformations. Okay, changes to the graph are called transformations. So parameter changes to the graph, parameter changes to the equation or to the function cause transformations to the graph. Okay, so we're in the process of finding out what the new points are. So if you plug in 0 for x, the absolute value of 0 is 0. 0 plus 1 is 1. Plug in +1. +1, the absolute value of +1 is 1. 1 plus 1 is 2. And plug in 2 and you'll get 3. Plot those points, -2, 3. Plot -1, 2. Plot 0, 1. 1, 2. 2, 3. Connect all of those, and what you'll see is a graph that is just a vertical translation of every single point that was on the parent function, just translated up 1. What do outside parameter changes cause? Outside parameter changes cause vertical shifts. Another word for shifts is translations. Okay? Vertical translation. So outside changes, numbers that are being added or subtracted, cause vertical shifts. We added 1, it causes us to shift up 1. So with that understanding, let's go over here. We know what our parent function looks like. Okay? And our goal, remember, is to 1, have the parent functions memorized. Yes, you're going to want them memorized. And be able to look at the parameter change and predict or actually execute the graph with the transformation, okay? Transformation is a generic term. It can mean lots of things. The transformations that we're going to be learning are transformations that are translations, reflections. We're going to do horizontal and vertical compressions and stretches, okay? But the particular one that we're studying right now are translations. Now this is, notice, it's an outside change. It's an outside parameter. It's an outside parameter. Okay, so an outside parameter causes a vertical change. And because it's added or subtracted, and in this case it's being subtracted, it's going to shift it. What do you think? If +1 went up 1, what do you think -2 is going to do? That's exactly right. It's going to shift it down 2. Every point 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 down 2. Are you tired of me saying that yet? Every point's going to be shifted down 2. Okay? So the parent function here, the transformed function down here. And again, you can go back to your graphing calculator and you can check it by pulling up your graphing line. Leave F1 the way it is. It's your parent function. Go back and get your template. Type in the X. Move outside your function. Okay. Get outside your function and then do the -2. And then hit enter. And it graphed it just like we said. It shifted it down 2. Here was the original one at 0, 0, went down 2. Same thing is true for Desmos. Oops. Desmos. Leave that one right there. Come down here. Type in the absolute value of X. And then hit -2. And again, it shows you. There's the absolute value of X, your parent function. And there's the one with the parameter change at -2. Okay, and you can see all these points. Okay, so let's see what the Springboard book says now. Okay, so we've done up 1, we've done down 2. What does multiplying on the outside do? We've got multiplication. Now, addition and subtraction caused, here we go, vertical translations. They shift up or down. We'll deal horizontal in a minute, okay? Now we're going to do a vertical stretch or a vertical shrink, okay? So we've got this one right here to go do. I think it's on the next page. Okay, they want us to do 3x. Now again, if we had to do it by a table of values, okay, we'd just simply pick x, and over here, would be the absolute value of x. Okay, plug in -2. The absolute value of -2 is +2. 2 times 3 is 6. Plug in -1. The absolute value of -1 is +1. +1 times 3 is 3. Absolute value of 0 is 0. 0 times 3 is 0. Absolute value of +1 is 1. 3 times 1 is 3. Whoops, that should be a +2. The absolute value of +2 is 2. 2 times 3 gives me 6. So I'm going to go back over here and put the parent function in one color. And you should probably be doing this too, using 2 different colors so you don't get them confused. You can use colored pencils, or you can use a pencil and a pen, or you can use 2 different colored pens. Okay, there's the parent function. Parent function goes through 0, 0, and it goes rise over run 1, rise over 1, -1. Okay. Now for the blue one, the blue function at 0, 0, it still has the same 0, 0, but at -2, it went up to 6. And at -1, it went up to 3. 0, 0. At +1, it went up to 3. And at +2, it went up to 6. Okay, so we still have this V going on. Okay. But what happened right there is each one of these Y values was multiplied or stretched by a factor of 3. So where it was 1, 1 times 3 became 3. Where it was 2, 2 times 3 became 6. So let's talk about this parameter change. It's an outside one. It's an outside parameter change. Okay, so we know it's going to cause a vertical change. Outside always matches with vertical. But it's an outside parameter change. It's an outside multiplication. Okay, outside multiplication. And I'm running out of time again. And since it's multiplication, it's not going to be a shift, but it's going to be either a stretch. In this case, it's a stretch. Or in some cases, it's going to be a compression. Okay, I got to stop.